When applying differential equations, we are usually not as interested in finding a family of solutions, the general solution, as we are finding a solution that satisfies some additional requirement. In many physical problems, we need to find the particular solution that satisfies a condition of the form y of the initial value of t is equal to the initial value of y. This is called an initial condition. And the problem of finding a solution of the differential equation that satisfies the initial condition is called an initial value problem. Geometrically, when we impose an initial condition, we look at the family of solution curves and pick the one that passes through the point of initial value of t, comma initial value of y. Physically, this corresponds to measuring the state of a system at time t, the initial value at time t, and using the solution of the initial value problem to predict the future behavior of the system. So for example 2, we want to be able to find the solution of the differential equation y prime is equal to 1/2 times y squared minus 1 that satisfies the initial condition of y of 0 is equal to 2. So because we're given that initial condition, we're going to say that t equals the input, which is 0, and y is going to equal the output of 2. And then we're going to substitute it in the equation from example number 1. So we know that y is equal to 2, and we know that t is equal to 0. So now we have 2, which is equal to 1 plus ce to the 0 over 1 minus ce to the 0. We know that anything to a 0 power is going to give you 1, so e to the 0 is 1 times c leaves you with c, and likewise for the denominator. So now we have 2, which is equal to 1 plus c divided by 1 minus c. Now for part 3, we want to solve for c. So we need to multiply both sides by 1 minus c. So we end up getting 2 times the quantity 1 minus c, which is equal to 1 plus c, and then solve for c. So combining like terms, solving for c, we know that c is going to equal 1/3. And now for step 4, we're now going to substitute c equals 1/3 into the function y equals 1 plus c equal e to the t divided by 1 minus c e to the t. So now that we plug in the value of 1/3 for c, now instead of leaving the fractions, we can multiply both the numerator and denominator of this fraction by 3. So we end up with y is equal to 3 plus e to the t divided by 3 minus e to the t. And therefore, this is a solution to the initial value problem.